This is the answers to the exponential marble slide. The marble slides are exponential functions. So here's the warm up. Is this exponential growth or decay? I can tell it's exponential growth. As I look at the graph from left to right, the y values are decreasing. The horizontal asymptote is right here, y equal -4. The domain from left to right, negative infinity to positive infinity, the range start at the bottom, -4 to infinity. As x approaches negative infinity, y approaches infinity. And as x approaches infinity, y approaches -4. And this just is showing you what you want to do with these slides is launch the marble so it collects all the stars. And number 3 is if I reset this, I want to move this over to the right. So if I make it -18, that works. So it's kind of slow, but it eventually collects the stars there. And slide 4 is just showing you how to reset the slide, get it back to where it started. Slide 5, we'll reset this one. So I want to move this up to here, so I want to make that +3. And then I'm going to move the graph over, so if I make it greater than -16, that should work. And then when I launch the marbles, actually hits everything. So I moved the graph up 3 units right here, the +3, and then change the domain to x is greater than -16. Slide 6, let me reset this one. It was 3 to the x +2. And then someone in the first period said if we just change this one, 3 to 1.1, change the multiplier so it makes the curve less shallow. And then when you launch the marbles, it collects all the stars. And number 7, let me reset this one. So I want the graph reflected over the y, so I want to make it a -x there. So -x in the exponent. And let me see. Yeah, just a -x in the exponent will work. So that gets everything. So if I change this 3 to +3, it translates up 6 units. And then let me reset this. So I want us to change this to +3. So here's the original, the dash graph, and then the solid one is the new one. So this actually moved up 6 units. And then if we change the -4 to +4, it's going to move 8 units to the left. And then let me reset this. It was this. They want to make this +4. So I need to get in there. Parentheses. X +4. All right, and then 12. If we change 2 to 1.2, what happens? It changes the growth factor. The graph would be increasing less rapidly. So let's reset this. It won't change this 2 to 1.2. So that flattens the curve there. And then 14. So if I want to, your phone won't give many stars like this. What changes would you make to the equation to help your friend collect all the stars? Why are those changes going to work? So make the exponent negative x and change the 3 to a 2. So what that does is the negative reflects the graph over the y-axis, and the 3 to 2 makes the horizontal asymptote change. So that's why that works. And then they want you to do that here. So put a negative in the exponent, change this to a 2, and then launch marbles. It collects all the marbles there. And then 16, they just want you to slide these things around, see what the transformations happen to the graph. So A is your dilation. Let's make it positive. A is the dilation, and then B, that's your multiplier. You notice that if it's between 0 and 1, then it shows decay. Same thing with A. If I make it negative, it shows decay. And then C moves the graph left or right. D moves the graph up or down. All right, and then we summarize that here. A causes a dilation when A is negative. You have exponential decay. B is the multiplication factor. It causes the graph to increase more rapidly or less rapidly. When B is between 0 and 1, we have exponential decay again. C translates the graph left or right. D translates the graph up or down. And then using the rules of exponents of this 2 to the third is 8 to the x, so we have the same graph. And the same thing here. Here's the original. I don't know why that one's not turning blue. Well, now it is. So I turn both of those off. Here's 1/3 of the 2x. Turn both of those off. There's 1/9 of the x. So all three of these graphs are the same. And then why is that true? 2 cubed is equal to 8, and 3 to the negative 2 is equal to 1/9. That's why that's true. And then these are the challenge slides here. So I'm not going to go through every one of them. It took me a while to find the right equation. So here I made an exponential decay, exponential growth, exponential decay. exponential growth, and then the marble is going to collect all those. All right. And then slide 2. I don't know if this is going to work. Let me see. Oh, yeah. I thought this might not be flat enough here, but it works. I mean, there's other equations you can put in there to collect the marbles, but like I said, it took me a while to find the right one. So this one, sort of like a parabola shape, so I used this first curve. Let me change the color of this one so we can see better. All right, so the red one, decay, the blue one, growth, or it's a reflection. These two graphs are reflected of each other. So I use the reflected graph there. And then slide 24, use the same kind of idea, a decay and then a growth hooked together. So it makes a U shape. And then here, use the flat curve here, exponential growth, and I mean exponential decay and exponential decay. So let me make these different colors here so let's see what's going on here. All right, growth, decay, and decay. If I launch the marble here, and then I use some restrictions on the domain in order to get these gaps here. Maybe some of you made some graphs that made it go quicker up here at the top, but that works. So, like I said, there's other equations you can put in there. And then 26, use this idea here. Go come down here, and then use this ramp kind of idea. The marbles are going to come here and then slide down here. So maybe some of you use less equations. I use 4 equations there to get this one to work. All right. And then 27, use the ramp idea again. So it's going to ramp up here, and then go off of this ramp and hit these. All right, so I used 5 equations there in order to collect all the stars there. 28, I use this seesaw idea again here. So decay, growth, decay, growth. So sort of a back and forth motion. To get these gaps, you have to use the restrictions on the domain there. All right, that's it.